torque control systems for Anderson Army Depot. As you can see, we have two identical systems. So each system consists of a control arm, manipulator arm, a 10-foot span on that, with a single spindle power head that's set to run at 750 foot-pounds. The 4-spindle with, I think, a 10 1/4 inch bolt center. I'm sorry, this is 750 foot-pounds, and that is, I think, set to 330 foot-pounds. And also we have a 5-spindle multi, that's 11 1/4 bolt center, also 330 foot-pounds. The arm articulates. It does have rotation stops up there that are adjustable. We don't have set now. We'll set those at install to the ideal working range. The system, there's a proc sensor for each of the 3 power heads there that detects basically when the system has been removed. And we have a 4-position regulator that's getting the signal from those proxies to change the air pressure to the arm, the cylinder there, to balance whatever system we're holding. We do have an up-down override for that, so no matter what you're lifting, whether it's empty or picking up any of these power heads, you can use the up-down to control, and it's needed when you set this down to actually lower the arm out, and then it's back in the unloaded state again. So one of the big advantages to this system over what you currently have, I believe, is the cable management. So right now, you have a tool cable coming from one of the controllers underneath to the tools. So there's a lot of festooning going on. One thing that we have with this system, the Cleco Intelligent Spindles, is we essentially have one tool cable coming from the controller, which is right here, to each power head. So you've got a tool cable for the 5-spindle, you have a tool cable for the 4-spindle, and you have a tool cable for the single spindle. And then for the controls, we have one IO cable coming from existing closure here to each power head. So it becomes a lot less messy. We have 3 balancers there, so as you attach this to the arm and are using it, this will flex out as needed. Of course, that's adjustable in position. And then when it's not used, we actually have it incorporated into the proc sensor cover just to keep it out of the way, when you're using one of the other ones. The controller, you have one controller that powers all 3 power heads, and we'll turn this on in a minute. You have all your tool programming, all your data storage, everything in this one cabinet. And the cables run down, and they're zip tied here. All the slack is out of the way, and we'll have a cover plate that we'll show you in a photo on the other system to sort of make that look neat. And then all the cables run up this conduit and branch off. Each cart includes an electrical hose reel, 50 foot of cable. It's got the Appleton 4-pin connector that you use, and a pneumatic hose reel, half-inch air hose, shut-off valve, and 50 foot of that. So I'm going to power up the system now first, and electrical on first. Let that power up. It'll take probably a minute to a minute and a half to load all the programs and settings. All right, so the system's powered up, it's loaded. I pressed the green button to initialize the spindles. All the tools have indicator lights on the tools, and they're all green, showing you that they are ready to run. So they all have independent start signals. 4-spindle, single spindle, and they all have their own reverse switch, indicator lights, and e-stop if you need to kill power, which is wired in series with the e-stop on the panel. So now I'll cut air on. It's powered up. All right, so air's on. Right now, the regulars don't have any proc sensors on because everything's in position. So the air pressure is set to approximately balance the weight of this. I kind of push the arm out to give it room, because as I raise up, the arm wants to come out, so just giving it clearance to clear that. So raising that up, I also have up button, down button, override, and that's flow controlled inside the panel to adjust the speed. We prefer it to be slow. So I'm going to push this around, and we've got our joint simulator over here. Get the right part of the arm moving. And we're going to start with the 4 spindle because the 5 spindle bolts are already tight, which we need to be able to run this. So I'm going to bring this in here like so. I'm going to raise up. All right, so took a break. We actually had to move our joint simulator here. We ran into an issue with the cables moving back that way, so we've got a little adjustment to do on that. And then the arm moves there. We just kind of, our conduit got in the way. So reset here, put that up. Regulator balances for the 4 spindle. Pull it out. Now we're going to bring that over. I'm going to try to stand back where you can see what's going on. So float the system up and down this to align, or you can use the up-down handle. Yeah, it's just a matter of preference. Get that lined up. The spindles are tracked, so I try to push into the sockets a little bit. And so, I don't know if you can tell what happened there, but we've got this set up to synchronize, so the tools ran to 50 foot-pounds, and they wait for all 4 to get to 50 foot-pounds, and then they all run in to 750 foot-pounds final torque, which will show on the screen. You know, the indicators here, we have an overlay coming in to actually mark these as tool 1, 2, 3, 4, and then it's labeled on the tool so you know what spindle it was. I'm going to put it in reverse. Back goes off, back into forward, and we'll actually run it again. Pause. Just going to back it off in case we're going to run it again later. Here. Move around to the other side, plug in everything. Down. I'm holding the down button now until all the air exhausts out. The flow control is set slow, so it takes a second. It comes down, slide that out. Now the arm is balanced for just the weight of the arm itself. All right, so now we're finished with the 4 spindle. We want to run the 5 spindle. So same process over here. Align that with the receiver. Up a little bit. There we go. And hooked up my tool cable there. That up, put it back. This side. Line that. Spin reverse. Same thing with the synchronization, 50 foot-pounds, they all wait. Once they get to 50, then they go up to, I think 330, and we didn't show this on the 4 spindle, but you can still see the results on the screen from the last rundown. So here we were 750 on the 4 spindle, and we're 335 there on the 5 spindle. So I'll back these off and run it again while it's in place, just so you can see the synchronization one more time. So just put it in reverse, they all back off, so back and forward, go here, stop, they all go up to 335. So I'm going to back these off because we'll use these same bolts to run the single spindle as well. Go over. Down, hold the down button. It'll take a few seconds to exhaust the air. And unhook the cable. Move right over to the single spindle. This one's a little different because on the 4 spindle and the 5 spindle, all the tools react off each other. So we just have this safety latch just to be sure. There, put that in place so it can't slip out. Same thing with the cable. bolt. So that went to 335 foot-pounds. A little bit of kick, not bad, but you don't have the other tools absorbing that torque reaction, so it's all transferred up to the arm. I'll back that off. And forward. Go. Green light. Not much room here. Hold this back up. We're done. Alright, so one thing I didn't show earlier when I powered it up, just have it I guess. So when it first comes on, you have to hit this green button to initialize the tools. So you hit the E-stop, all the tools are red, nothing works as far as the start handles or the tools are concerned. So when you release the E-stop, you have to press the ready button and the tools turn green and they're ready to go. Every tool, 5-spindle, 4-spindle, single spindle, has an E-stop on it as well. So I'm just going to hit one at random. And again, it kills the power to all of these. It is wired in series with the other E-stop. So when that's released, you still have to come over here, cycle that, and then the ready button, and they're all ready to run. Okay, so this panel is for all of the 24-volt I/O. So basically, it's the tool start, the tool E-stop, the tool forward reverse, the tool indicator lights. There's one cable that comes out of the master controller into here where we split off all of the I/O wires, which would be on the drawing, but everything's labeled. It's kind of a common sense labeling, you know, like 5SP01 would be output 1 for the 5-spindle fixture and so forth. So all that's labeled, it's in there, it's its own terminal blocks. And then up top, you'll see these 3 relays. Those relays are only for the balancing of the regulator between the 4 positions: the unloaded, the 5-spindle, the 4-spindle, and the single spindle. So when the prox energizes, then it will actually fire the relay, which sends the signal up to the regulator. So I'm going to raise this up just to get the prox on. Now if we come over here, you can see that the relay for the single spindle is lit up, telling you that that's the pressure that's set. And I'll show the inside of the pneumatics enclosure in a second as well. Okay, so now I've got the pneumatics enclosure open, which is the one that's on the top arm. And you can see that the regulator is set to 30 PSI, and the 30 PSI correlates to the single spindle being lifted, as I showed just a second ago. So that's the way the air flows through the regulator out to the cylinder as the primary. And then if you were to hit the up or down button, basically we have these pilot check valves that override that, so that you're using, I guess, the plant air supply, whatever pressure that's set to raise it. So, you know, you'll overcome the air pressure and you raise that up, it'll lift the 5-spindle, 4-spindle, you know, and you don't have to pull up or down on the arm to do it. And then as soon as you let off the button, then the pressure defaults back to the regulator. This valve and binary valve up here in the top right corner are for the brake, which I haven't shown yet, and I'll do now. So you got a single button on the control handle for the brake. I guess first let me show this. So I'm going to lower this back down into this fixture. There we go. Exhaust in the air. Pull this out. And so I'm pulling this. I'm going to hit the brake button, and now it's locked. So you have a brake here at this mid pivot, and you have a brake back here on top of the column as well. So they're both plumbed in series and both work off the same button, same valve. So that'll hold its position. Hit the button again, same button, and now it's free to move. So I'm gonna lock the brake, and then I want to point to the regulator now that we don't have anything attached, and you can see that the air pressure is at 11 psi, which is all is needed just to float the arm with no tooling on it.